Welcome to Nimu's World. It's me Nimesh Naik. Today I am discussing CSIR Net Questions June 2019. Topic Abstract Algebra. It's a part C question. Let F27 denote the finite field of size 27. For each alpha belongs to F27, we define A alpha is equal to set of all 1, 1 plus alpha, 1 plus alpha square, 1 plus alpha square plus alpha cube, etc. Then which of the following are true? Option number 1. The number of alpha belongs to F27 such that cardinality of A alpha is equal to 26 equals to 12. And option number 2. 0 belongs to A alpha if and only if alpha not is equal to 0. And option number 3. Cardinality of A1 is equal to 27. And option number 4. Intersection alpha belongs to F27. A alpha is a singleton set. To solve this question, we want to know the following result. So result number 1, if F is a finite field, then F star under multiplication is a cyclic group of order of F minus 1. That is F star dot F star under multiplication, which is isomorphic to set of order of F minus 1. And the result number 2, if F is a finite field of order P power n, then F is isomorphic to GF of P power n. And result number 3, if F is a field, then characteristic of F is either 0 or P, where P is a prime number. Now we are going through the options. Our first option says that the number of alpha belongs to F27 such that cardinality of A alpha is equal to 26 equals to 12. For this, given that F27 is a finite field of order 27, which implies that F27 star under multiplication is a cyclic group of order 27 minus 1, that is which is equal to 26. That is the order of F27 star under multiplication is 26. Then the number of generators of the cyclic group F27 star is 5 of 26. By calculation, we get 5 of 26 is equal to 12. So our option number 1, which says that the number of alpha belongs to F27 such that cardinality of A alpha is equal to 26, which is equal to 12. That is the number of generators of the cyclic group F27 star, and which is equal to 5 of 26. By calculation, we get 5 of 26 is equal to 12. So which is equal to, given the our option is says that which is equal to 12. And we get 5 of 26 is equal to 12. So our first option is a correct option. Our second option, which says that 0 belongs to A alpha if and only if alpha not is equal to 0. So we take the first part, that is if 0 belongs to A alpha, which implies that alpha not is equal to 0. So for that, if possible, take alpha is equal to 0. If we taking alpha is equal to 0, then we get A naught is equal to 1. Because A alpha is the collection of 1 plus alpha, 1 plus alpha square, etc. So here alpha is 0. So we get A naught is equal to 1, and which does not containing 0. That is A naught, if taking alpha is equal to 0, A naught is equal to singleton set 1, and which does not containing 0. So we get a contradiction because 0 does not belongs to A alpha. This is because we taking alpha is equal to 0. So we get a contradiction. Therefore, 0 belongs to A alpha implies that alpha naught is equal to 0. So our first part is done. Now for the reverse part, that is if alpha naught is equal to 0, which implies that 0 belongs to A alpha. So for that, if alpha naught is equal to 0, then alpha belongs to F27 star. And let M be the order of alpha. That is alpha naught is equal to 0, which belongs to F27 star, and we take M be the order of alpha. Then by definition, alpha power M is equal to 1, which implies that alpha power M minus 1, which is equal to 0. Here we can see that 1 is a root of this equation. So we get, which implies that alpha minus 1 into alpha power M minus 1 plus alpha power M minus 2 plus etc. plus 1, which is equal to 0. That is either alpha minus 1 is equal to 0 or this term will be equal to 0. So alpha minus 1 is equal to 0 implies that either alpha is equal to 1 and alpha is equal to 1 belongs to A alpha, because A alpha is the collection of 1 comma 1 plus alpha, 1 plus alpha square, etc. And also alpha power m minus 1 plus alpha power m minus 2 plus etc. plus 1 is equal to 0, which is also belongs to A alpha. So our reverse part is equal to 0. So sorry, our reverse part is true, that is we are done. So our second option is also a correct option. Now for the third option, which says that cardinality of a1 is equal to 27. Now we take alpha is equal to 1, then our collection a alpha is equal to, if alpha is equal to 1 plus alpha, 1 plus alpha square, etc. So when we taking alpha is equal to 1, a1 is equal to 0, 1, 2. This is since our characteristic of F27 is equal to 3. So that is we get the cardinality of A1 is equal to 3, which is not is equal to 27. Our third option is says that cardinality of A1 is equal to 27 and we get cardinality of A1 is equal to 3. So our third option is also wrong. Now our fourth option, which says that intersection alpha belongs to F27, A alpha is a singleton set. Now for each alpha belongs to F27, A alpha containing the element 1. Because if we are considering A0 is equal to singleton set 1 and A1 is equal to set 0, 1, 2. So the intersection alpha belongs to F27, A alpha containing a singleton set 1. So our fourth option is also true, because which says that intersection alpha belongs to F27, A alpha is a singleton set for each A alpha which containing the element 1. So we can conclude that intersection alpha belongs to F27, A alpha containing a singleton set, that is singleton set 1. Okay, but then our fourth option is correct. So the correct options of this question are option number 1 and option number 2 and option number 4. Okay, thank you. If you like my video, please subscribe my channel and also like.